With the demographic expansion, with the growing megalopolis, with the global warming and the climate change, with the galloping desertification spreading to numerous parts of the globe, more than ever, water is and will be precious. Its consumption, its usage and recycling will be part of the most important ecological and economical issues facing humanity in the coming years. Today, there are numerous organizations which have been developing recycling systems throughout the world. Aravind Eye Hospital, located in South India in Tamil Nadu, close to Pondicherry, is one such example. The few strategies for disposal of untreated sewage in India have focused mainly on implementation of conventional treatment technologies. These centralized treatment plants require high capital investment, continuous power supply, high maintenance costs, and skilled operators. Very few municipal centralized treatment plants can claim to operate properly. In recent years, decentralized wastewater treatment systems have emerged, whereby units, such as communities, companies, hospitals, or households, can operate their private recycling system. This system is called DWATS, Decentralized Wastewater Treatment System, a technology which promotes the principle of conservation of natural resources for the protection of the environment. It is achieved by using methods that utilize the natural physical principles combined with the biological activities of microorganisms, which grow naturally in the wastewater. By reproducing and fine-tuning the treatment processes which occur in nature, engineers can create systems which optimize the natural treatment cycle in the most efficient and cost-effective way. Inaugurated in February 2003, Aravind Eye Hospital has chosen to use the DWATS system. This hospital has an infrastructure for accommodating 725 beds, with the outpatient section and the quarters destined to lodge an important staff. There are also the daily consultations of numerous patients, family visits, and all the water consumption that can represent the functioning of such a campus. Aravind Eye Hospital treats more than 310 cubic meters of wastewater each day, which represents today one of the most important natural, decentralized wastewater treatment systems in Asia. In the pre-treatment, the two water streams, grey water from sinks, bathrooms and kitchens, and black water from toilets, are collected and pre-treated in two separate settlers, which are underground constructed tanks. There, the contaminants are retained by flotation and sedimentation, which happens through the natural separation of the heavier particles, which sink down, and the lighter ones which float. Because of the pollution load, the black water is distributed in 3 baffled tank reactors. In these tanks, an anaerobic treatment takes place based on the metabolism of specialized bacteria, which will transform the organic pollutants into bacterial mass. During this process, the fresh influent is mixed with an active sludge blanket deposit of microorganisms occurring naturally at the bottom of each chamber. Through this progression, the accumulated sludge is gradually reduced. At this stage of the treatment, the average reduction of BOD is around 75%. The grey water, because of its lesser pollution load, joins the black water into the second treatment phase. In the second treatment phase, a device called an anaerobic filter is used. There are 2 of them in Aravind Eye Hospital. Before the wastewater enters the second phase, it is directed through a series of distribution channels, which regulate an equal distribution of the wastewater flow. It is here that engineering skills and strict quality control become essential for an assured optimum functioning of the whole treatment system. Inside, pipes direct the water stream between the chambers from top to bottom several times in a row. The chambers are constructed in series in order to digest the remaining degradable substances with the help of a filter material which provides a breeding or carrier place for bacteria, allowing a larger contact surface for the wastewater during the passage. In the anaerobic filter, the water undergoes a high-performance treatment, guaranteeing at the outflow a very low risk of contamination, essential for the sanitary standard of a hospital. At the end of this treatment, over 90% of the original pollution load is removed. But since the system works in a close environment and does not come in contact with oxygen, the effluent will still smell. At Aravind Eye Hospital, the water is pumped up to a rooftop buffer tank using 2 pump sets. The release from this tank ensures an equal distribution at the right pressure during 24 hours to a third device called a planted gravel filter. In the horizontal planted gravel filter, the treatment acts through the combined effect of filter material, such as pebbles, granite stones, the plants, and their roots. The wastewater travels through the gravel material, where it is reoxygenated by the roots of the plants. The outcoming effluent is free of odour. Due to the excellent treatment taking place in the previous 2 phases, the planted filter necessitates less space. This results in a drastic cost reduction and larger amounts of reusable treated wastewater available. In the last phase, the treated sewage is exposed to nature and becomes alive again by flowing through an open-air body called polishing pond. The water undergoes further biological treatment through natural UV exposure, which will eliminate pathogen germs. In order to recreate a natural water habitat, the pond is stocked with fish, which control the mosquito larvae together with naturally occurring frogs and dragonflies. Aquatic plants are used to control algae explosion. The only visible features of the whole treatment cycle are the planted filter and the polishing pond, which are aesthetically integrated into pleasant gardens. 50% of the total wastewater flow is reused for irrigation. The quality required for this purpose is obtained after the water has travelled through the planted gravelled filter with a BOD effluent quality below 25 milligrams per litre. The remaining flow is further treated in the polishing tank for use in toilet flushing with a BOD below 10 milligrams per litre. With this recycling, Aravind Eye Hospital saves more than 100,000 cubic metres of fresh water every year. Every 15 days, and for several months, samples are collected in every phase of the treatment in order to verify that the water quality conforms to national standards.
We are just checking the sport parameters here. That's pH, DO, conductivity and temperature.
Temperature 1.3. DO 1.76.
The maintenance is nearly free and is reduced to yearly desludging of the settler, gardening work and irrigation. The combined natural, physical and biological treatment allows the DWAT system to take care of itself. With a decentralised wastewater treatment system, we therefore avoid heavy mechanical equipment. We minimise the maintenance while providing great reliability and affordability. DWAT's India programme, with a network of 25 partners all over India, is disseminating this technology as a viable solution for different sectors. Aravind Eye Hospital is one such example out of many other functioning systems.